Here we are back with even more math fun for you. So let's go ahead and look at this one. This one is one that they already gave you the graph, so no equations. Kind of hard to find a way to use Desmos, so I'm sorry for you Desmos lovers like me, but we'll figure it out. It's wanting to know where the graph is increasing, decreasing, positive, and negative. I'm going to start with positive and negative. When it means graph is positive and negative, it means basically whether it's above or below zero. So just look at that line right there and just say, where is this graph above zero? It would be positive. So one place it is above zero or positive is between -4 and -1. So -4 to -1 to me seems a good option for where it is positive. Well, and then where it is negative would be below zero. So at one place it would be negative is from -1 to +3. That's not an answer choice. Another place it would be negative is over here beyond -4. So it's definitely positive there. That would probably be the best answer. We'll come back to the negative thing, and maybe it'll become clear as we look at some others. It also wants to know a place where the graph is increasing. Increasing means going up, so the graph starts off increasing and it increases all the way there. The graph is also increasing here. So it might not have the whole interval, but it'll have at least part of it. So the question is the graph increasing between -2 and 0? So between -2 and 0, it's absolutely not increasing. Actually, between -2 and 0, it seems very much to be decreasing. So I'm going to go ahead and mark that one as decreasing for -2 to 0. So that's gotten rid of 2 of my answer choices. And on your test, you'll actually drag these into the right place. And then on the next one, let's see. I'm still looking for an increasing, so is it increasing between 0 and 2? Well, when x is 0 to x is 2, the graph does seem to be increasing, so that seems like a good answer there. And then just to check and see, is it negative everywhere between 0 and 4? And it's not, so I've done something wrong maybe? Maybe. It's not negative between 0 and 4, so that won't work. So what I'm going to have to do is say, well, between 0 and 4, it is also increasing. So I could maybe use 0 to 4 for increasing. Kind of have to play with these. And then the negative, then, if that's 0 to 4, could this be true for negative? Yes, it could. So the good news is on those on the exam, you can kind of move them around from place to place. And if you get one in the wrong place, be like, hey, I don't have anything to go there. We'll double check and see if one of the others you'd put there, and I noticed, hey, this one would also work here, so I could move that one there, and then that one could go there, and just kind of have to play around with it till you get the right answer on this one. Not my favorite type of item, but it's manageable if you take your time with it. On this next one, you have a function, and it wants to know the distance between two zeros. That is just begging me to do Desmos, and after the last one, I'm having Desmos withdrawal. So here we go. I'm going to go ahead and type in the h of x because I miss Desmos so much. Probably don't have to do that on this one. 4x to the third minus 5x squared minus 23x. And reading to make sure I have it typed in correctly. That's good. And I'm looking for zeros that are close to each other. Well, it's kind of hard to tell for sure which zeros are close to each other. Those look pretty close. Let's see. So I have a 0 at -2, another one at 0.25, and another one at 3. So I'll just write these zeros down in order. -2, 0.5, and 3. And just double check and make sure I have my zeros right. I do, but it's a 0.25, so good thing I double checked. Okay, so I might say how far apart are these? Well, we can find out how far things are apart by subtracting. So 3 minus 0.25 is 2.75. On the other one, I can do 2 minus that would be a 2.25. And if you happen to get a negative, just ignore it because distances can't be negative. So what's the distance between the zeros that are closest? In other words, we're looking for the smallest distance between zeros, which would be 2.25. So another unique problem, but we got the answer with the help of Desmos, kind of giving us all the zeros. Making an organized list did help us out a lot. Okay, this one wants to know which function does not have all real numbers in domain. Remember, domain of a graph is x values, range is y values. So I'm basically going to be looking for a function that has a gap in its x values, or a problem with the x's. Now, if you remember a few things about domain, you might could speed yourself up. Like this first one, for example, I don't see anything that I could not plug in for x. So it looks like it's got a domain that keeps on going, and you might be tempted to say, well, it stops, but if you zoom out, it keeps going over, although it's going very slowly. So I think A is probably okay. B, on the other hand, there might be something for B that might make that not equal to 0. Might make a problem with the domain. In fact, if you look here, you'll see there's a gap in the graph. The graph kind of skips over 3. It gets close to -3 on this side, close to -3 on this side, and it skips it. In fact, even if you convert this to a table and try saying, well, tell me what the value is when x is -3, it's going to tell you it's undefined. So that one is the one with the domain problem. Even one like D, that might be a little weird to you, it's going to keep going. So if it keeps going on the x's, if there's basically, I can pick any x value I want. That means the domain is all real numbers. The one that is not is answer choice B. So B, and the actual domain for that would be, the domain would be the x values other than -3, because we found out putting a -3 in for x puts a 0 in your denominator, and that's not allowed. You can't have a 0 in the denominator because you can't divide by 0. Okay, this equation we're solving for x to the nearest 10,000th. I've got several options. I could try to do this algebraically, but I'm feeling Desmos. So here we go. If I'm doing Desmos on this one, I'm going to do 9 to the -3x plus 2. Okay, now one thing notice with Desmos is if you do have something fancy in your exponent, you do have to put the exponent in parentheses, or it gets really angry about doing that. And it tells you it is equal to 48. And you notice it gets angry and gives me that because it says, hey, I don't like it if you have things on both sides of the equation usually. So you can minus 48. And we're looking for a 0. And there it is, answer choice A. Now, I'm going to very quickly show you how to do this one algebraically because I have seen some questions on the exam that instead of giving you the decimals, they leave it in log form. So basically, to solve this, if I've got a variable stuck in the exponent, I do need to rewrite it as a log. So that means I'm going to have a log base 9 of 48 equals -3x plus 2. To solve, I would need to subtract 2 from both sides. And remember that 48 is inside the log, so just like you couldn't subtract 2, if it was inside a sine or a cosine or a square root, you can't subtract 2 there. In fact, maybe it's helpful to put that 48 in parentheses so you just know not to mess with it. Then I have this -3, so I would need to divide by -3. So you might see this written algebraically as this on another question. And just to show you how I could type that in Desmos and it would match up. Taking a little extra time here, but hopefully we're teaching you some valuable things. I could do log with a base. Now base I can do a shift and the minus. The shift and the minus gives me a base, or the other way I can get that is I can pull this up. Well, I'm going to have to make Desmos bigger to show you all that. I can pull this up, go to functions, and then under miscellaneous, choose the log with a base. That's probably the easier way for most of y'all. But it was a log base 9 of 48. And then we'll make it smaller again so we can see it needed to have a -2. And then the whole thing needed to be divided by -3. And notice that gave me the same answer I got the first time. One other thing while we're here, there's something called change of base. It says if you have a log base 9 of 48, you could see that rewritten. Basically, they split it into 2 logs by doing log of 48 over log of 9. I almost think of it as the tail of the log kind of grows and splits it in 2, so I have a log of 48, log of 9. this is the same thing as this. So if you check that in Desmos, the decimals will match. A lot of extra stuff there. But hey, that's why I recommend graphing it in Desmos. It's the easy way to get the answer. And if they did give you something like that, you could always put it in Desmos and play matchy-matchy with your decimals and get it right. Okay, number 20 is probably one of the most interesting ones we've done so far. First of all, it uses this word unit circle, which some of you may or may not be familiar with. Unit just means 1. So a unit circle, it just means this side they've drawn here has a length of 1. And they tell you M has an X coordinate of negative 1/2, and they didn't tell you the Y coordinate. But what that means is I can draw a little triangle here. And since it has an X coordinate of negative 1/2, I know I had to go over negative 1/2 to get there. And I know this is 1. So now I can basically say, well, what trig function am I dealing with here? And the trig function I'm dealing with, to deal with that angle that's at the origin, would be cosine, because this is the hypotenuse, this is opposite the angle at the origin, this is adjacent. So I have adjacent of 1/2, a hypotenuse of 1, that's cosine. So I could say cosine of theta equals negative 1/2 over 1, which would just simplify to cosine of theta equals negative 1/2. Now at this point, I would like to know what theta is. And notice it says in radians. So we're going to have to be very careful as we use Desmos here. So what I can do is I need an inverse cosine to get rid of that. So I'm going to go to my functions and functions trig, and there's my inverse cosine. So inverse cosine of negative 1/2 and then that is giving me an answer that's probably in degrees, looking how pretty it is. So the next thing I'm going to have to do is I'm going to have to do the wrench and change it from degrees to radians. So under your wrench, you can change from degrees to radians. As it says in radians, it's that. So now I have an answer of 2.09, which unfortunately also does not match any of your answer choices. So I'm a little dumbfuzzled here, and I'm like, okay, I'm not sure what to do. And the truth is, I could figure this out. Basically, there's something with cosine. The best thing to do at this point, when you're just a little dumbfuzzled, is to say, okay, let's try plugging in answer choices. And you're like, well, what can I plug them into? I can plug them into this equation that I've written here in blue. So I'm like, Desmos, you failed me once. Don't fail me again. Please, when I try, plug in the answer choices. Help me to find this answer. So make sure you're still in radians. Cosine, once again, make sure you're still in radians, and I am. So cosine of my first answer choice is 4.712, is nowhere close. Cosine of 4.189 is really close to negative 1/2. Negative 0.49 is really close to negative 1/2. I think that's probably the answer. If I keep going for C, nowhere close. D, also nowhere close. And if you get confused about the decimal, you can always type in negative 1/2 and it can give you the decimal, and you can say, hey, the best answer from the ones I have there by plugging in answers into the equation I think's right is that. That one's a little tough, but hopefully if you know some trig and you use Desmos, you'll get it, and we'll try to help you out with some more on the next one.